You've seen pictures of Mars before, but probably not like this. These aren't artist impressions or colorized guesses. They're real photos, taken by actual cameras, on real machines, sitting on the surface of another planet. Photos showing the ground, the sky, the shadows, the cliffs, everything exactly as it is. No filters, no fiction. Most people have no idea how much of Mars we've actually photographed. We've got thousands of raw images, from rovers like Curiosity and Perseverance, from orbiters circling the planet, and even from a flying helicopter. Some of these shots show signs of ancient rivers. Some show rocks that formed in water. Some show chemical clues that scientists still don't fully understand. In this video, we're going to look at the real images of Mars, what they show, why they matter, and how they're changing what we know about the planet. And the more you look at them, the harder it is to ignore one question. Why does a dead planet look so familiar? When you think of a camera, you probably picture something handheld, something you can point and shoot. But the cameras that give us these images of Mars, these aren't regular lenses. They're scientific instruments. Precision machines bolted onto rovers the size of small cars, crawling across a planet where the dust never settles and the sunlight has a colder touch. Every photo they take is a product of engineering, risk, and patience. And more than anything else, perspective. Right now, there's a robot named Perseverance sitting in Jezero Crater. It's not just taking snapshots, it's conducting one of the most complex geological surveys in human history. Its cameras aren't there for pretty pictures. They're there to map textures in the soil, read patterns in layered rocks, scan distant hills for signs of erosion, and identify the exact chemical composition of a random pebble on the ground. Some of these images come from Mastcam Z, a stereoscopic camera system that can zoom in on a rock from hundreds of meters away and still tell if it's sedimentary or volcanic. It doesn't just see color, it sees context. It's not looking at Mars the way we do, it's decoding it. And it's not alone. A few meters above it, sometimes buzzing overhead like a mechanical dragonfly, is Ingenuity, a helicopter that was never supposed to last more than a few weeks. It's now flown over 70 missions across 3 years, capturing aerial views of Mars no human or machine had ever seen before. From above, the ground becomes more than terrain. It becomes story. You see ancient river deltas from a new angle. You trace paths worn down by time. You get a bird's eye view of another world. Something no one thought was possible before this tiny rotorcraft took off. And then, far above all of it, orbiters like Mars Reconnaissance Orbiter stare down with their own high-resolution eyes. They map every crater, every dune, every frost-covered pole, creating layered archives of Mars through the years. These images aren't just pretty, they're geological timelines. You can look at a single high-rise image and see billions of years of planetary history compressed into a color-shifted strip of terrain. But what's powerful here isn't just that we have these machines, it's that we built them to see what we couldn't. These aren't images taken for tourists. They're taken for scientists, for skeptics, for dreamers, and they've quietly accumulated over decades into the most detailed visual archive of another planet that humanity has ever created. Thousands of images, dozens of angles, multiple machines, all converging on one goal: to understand a world that's both alien and strangely familiar. And when you look at these images, raw and untouched, something strange happens. You stop thinking of Mars as that red planet in the sky. You start feeling like you've actually been there. Like the camera isn't just showing you a rock, it's showing you a place with wind, with silence, with scars, and maybe, just maybe, with secrets. Before we keep going, here's something quick, but important. If you've ever looked up anything about Mars, black holes, or whatever weird corner of the internet you ended up in, there's a good chance someone's tracking that. Your internet provider, random websites, even apps you forgot you installed years ago. That's where today's sponsor comes in, Surfshark VPN. Surfshark encrypts everything you do online. So whether you're reading about Mars riverbeds, ancient fossils, or digging through raw NASA images like I do, Nobody can trace your digital footprints. Not your internet provider, not advertisers, not that one shady cookie pop-up you accidentally clicked. And it gets better. Surfshark lets you change your virtual location, which means you can unlock content from other countries, like region-blocked documentaries, geo-restricted space research tools, or even cheaper subscription prices in other countries. Surfshark isn't just a VPN. It's part of a whole security package. You get a Surfshark alert, which lets you know if your personal info gets leaked online. You also get Surfshark antivirus to keep your devices clean. So if you care about privacy, security, and not being tracked while you browse online, Surfshark's got you. Head to surfshark.com/Fexel or just use the code FEXEL at checkout to get 4 extra months of Surfshark VPN. Mars doesn't have forests. It doesn't have oceans or clouds drifting lazily through a blue sky. But it has something just as haunting. Silence, stillness, a kind of quiet that feels ancient. When you look at real images of its surface, you're not just seeing another planet. You're staring at a place where time stopped moving a long time ago. Jezero Crater, where Perseverance is currently exploring, is a perfect example. To the untrained eye, it might just look like a dry riverbed, a dusty floor surrounded by hills. But every photo of that crater is a geological crime scene frozen in time. The layered cliffs you see in the background, those are ancient sediments, stacked over millions of years like pages in a book. You can follow those lines and read Mars's history. When water flowed, when it dried up, when it came back, and when it disappeared again for good. Now zoom in. That ridge over there isn't just a pile of rocks. It's what's left of a delta. The place where a river once met a lake. You can literally see where the flow split into fingers, spreading sediment across the basin. You don't need imagination to picture it, just the image. A real photo, from a real place, taken by a robot on a world where water once carved valleys just like it does here on Earth. Other landscapes captured by Perseverance and Curiosity look even stranger. Some areas are cracked open like broken pottery, dry mud that hardened into patterns that suggest water once pooled there and slowly evaporated. In one photo, you'll see what looks like a stack of broken tiles, each a layer of mineral-rich clay that settled quietly over time, undisturbed. In another, you might spot a perfectly round stone half buried in dust, sculpted not by hand, but by years of slow rolling in ancient Martian streams. Then there are the highlands, places like Mount Sharp in Gale Crater, where Curiosity has been climbing for years. Its images show towering walls with streaks of color, pale yellows, rusty reds, deep browns. Each stripe marks a different chapter in Mars's climate history. The higher the rover climbs, the further back in time it goes, like walking backward through a forgotten era. It's not just a mountain, it's a timeline. Even wind leaves its signature on Mars. Dunes twist across the surface in delicate wave patterns. Dust devils leave faint tracks like brushstrokes across a desert canvas. These features aren't just visually stunning, they're alive in their own way. Because even though the planet feels dead, the surface still shifts, reshaped by the thin Martian breeze. And yet, for all these powerful landscapes, nothing moves. There are no animals, no people, no signs of life, just rocks and dust, and a camera capturing it all. That's part of what makes these images so heavy. They're not just photos of places, they're snapshots of a world where everything stopped millions of years ago and stayed that way. And as we look closer at these still, silent frames, it becomes harder to ignore the question lurking beneath every photo. If this place once had rivers and lakes and energy and motion, what happened? Where did it all go? Because that's what makes Mars more than just a rock. It's a memory, a frozen memory we're slowly learning to read. There's a strange thing that happens when we stare at images from Mars. At first, we admire the landscape, the cliffs, the dunes, the broken rocks. But then something catches the eye. a shape, a shadow, a figure that looks just a little too familiar. And suddenly, you're not just looking at a photo of rocks. You're trying to figure out if that rock looks like a helmet or a face or something watching back. This isn't new, it's been happening for decades. Ever since the Viking missions in the 1970s sent back the now famous image of the so-called face on Mars, a formation in the Cydonia region that looked uncannily like a human face staring straight into the sky. People ran wild with it. Alien theories, ancient civilizations, pyramids. Later images, in higher resolution, showed it was just a hill casting odd shadows. Nothing more. But the damage was done. Mars had given us a taste of something eerie, and we've been seeing faces in its rocks ever since. It's called pareidolia, the brain's natural tendency to find patterns where none exist. It's the same reason you see animals in clouds or a man in the moon. But on Mars, pareidolia takes on a life of its own. Because when you're staring at a silent, barren world, your brain craves something familiar, and sometimes Mars obliges. One of the most recent examples is the angry face rock spotted by Perseverance. The photo went viral, a boulder with two indented pits and a jagged line underneath, like eyes and a grimacing mouth, sitting in the middle of nowhere. It's probably just erosion. A coincidence. But the face feels expressive. It looks annoyed, like the planet itself is tired of being poked and prodded. And then there's the so-called doorway photographed by Curiosity in 2022. A narrow opening in a rock wall, clean and vertical, like something carved into sandstone. Some claimed it looked like the entrance to a bunker. Others said it was just a fracture, nature's way of splitting rock under stress. NASA even confirmed it was only a few centimeters tall. But it didn't matter. The image had already triggered that feeling. The idea that maybe, just maybe, we're not looking at natural formations anymore. There have been alien statues, crabs, fossils, and even a crashed UFO in past images. All tricks of light and shape. But whether these objects are meaningful or not, the emotional impact is real. Because what we're reacting to isn't the rock. It's the possibility. That subtle suggestion that something unknown might be buried here. That this empty planet still holds stories we haven't uncovered. Of course, most of it is just that, suggestion. But these moments matter, because they show how powerful raw imagery can be. Not when it's explained, not when it's filtered, but when it's simply presented as is. Just a dusty photo from a distant machine, left open to interpretation. And in that space between certainty and imagination, something strange happens. Mars starts to feel less like a place we're studying, and more like a place we're haunted by. Not because of what's there, but because of what we think we see. And maybe that says more about us than it does about Mars. The images taken from the ground are already impressive, but they only show one angle. What changed everything was the day a tiny helicopter took off into the thin Martian air and gave us a completely new view of the red planet. That helicopter is called Ingenuity. It wasn't built to be a long-term explorer. It was meant to fly a few short test hops just to prove flight was possible on Mars. That was it, but it kept going. And today, it has become one of the most valuable tools for capturing real images from above. Though Ingenuity is no longer flying, having taken its final flight in January 2024 after suffering rotor damage, it remains active on the Martian surface, still operating locally by gathering environmental data and serving as a stationary data relay and observation platform. When you look at the aerial shots taken by Ingenuity, the ground suddenly transforms. Features that seemed flat from the rover's cameras now take on structure. You can clearly see erosion lines, collapsed cliffs, and the shape of old stream beds. One particular image shows Perseverance in the distance, parked like a toy on an endless dusty canvas. That photo wasn't dramatic, it was simple but powerful. It reminded people just how far away we really are, and how small even our most advanced technology looks on another planet. Another photo captured a wide-angle view of Cetus, a region filled with layered rocks and textured terrain. From the ground, the area looked like a series of slopes and boulders, but from above, it became obvious. It was an ancient, eroded surface, maybe once covered by flowing water, now stripped bare by time and wind. These details help NASA decide where to send the rover next. A single aerial photo can change the entire mission path. What's even more interesting is how these aerial images help with context. When you see a close-up of a rock from Perseverance, it might not mean much by itself. But when you look at that same rock from Ingenuity's point of view, you start to see where it came from, how it fits into the bigger picture. It's the difference between seeing a brick and seeing the whole wall. There's no zoom effect, no color correction, just raw, quiet visuals from above, a world that still has no roads, no buildings, no movement. The only object flying there is something we built. And somehow, these simple flights, these grainy, steady images from an $80 million experiment, have become some of the clearest, most valuable eyes we have on the Martian surface. They show us terrain that rovers might not reach. They scout safe paths forward. They reveal how light hits the land, how shadows stretch across dunes, how elevation changes where the wind leaves its mark. Ingenuity doesn't take dramatic shots. It's not a drone made for cinematics. But what it gives us is raw, real, and honest. Just a camera in the air, pointing down at a planet that most people have only seen in fiction. And those images, taken by a flying machine with rotors thinner than cardboard, are helping to tell the most accurate visual story of Mars we've ever had. And the best part is that we didn't even expect it to last this long. Every image it sends back now is a bonus. It's easy to scroll past a photo of rocks and dirt and think nothing of it. But scientists don't see these images the way most people do. To them, every layer of sediment, every crack in the ground, every color difference in a photo is a clue. The images we're getting from Mars aren't just for show, they're data. And some of that data is starting to suggest that Mars was once a very different planet. Take the recent discovery in Noach's Terror as detailed in a recent study led by Adam Losakut. A high-resolution orbital image revealed something surprising. Channels. Thousands of them. Almost 15,000 kilometers of branching, twisting formations that look almost exactly like dried-up river networks on Earth. These weren't noticed before because they're subtle, buried under dust, only visible when you know what to look for. But with better imaging and software to analyze terrain shadows, they stood out. And just like that, Mars's past became a little clearer. These weren't the marks of trickling water. These were river systems, real ones, large enough to reshape the land. Now match that with what we're seeing on the ground. Curiosity has spent years climbing Mount Sharp, photographing the cliffs and sediments layer by layer. In some images, you'll see clear divisions, bands of lighter and darker rock. These aren't just natural stripes, they're signs of climate shifts, wet periods, dry periods, evidence that Mars didn't just get wet once, it cycled through seasons. It had patterns, possibly even something like weather. Then there's the boxwork formations captured by Curiosity in June 2025. From a distance, they look like spider webs in the rock. Strange, organized networks of thin ridges crossing over each other. Get closer and you realize they're mineral veins. These only form when water moves through rock, leaves minerals behind, and then evaporates. In other words, these photos are showing you the fossilized path of water moving underground. It didn't just rain on Mars, it flowed beneath the surface. For a long time. Perseverance, on the other hand, is finding something even more important. Potential chemistry for life. Some images of its drill sites, like the one at the Cumberland Outcrop, show powdery, discolored rock. Doesn't sound exciting until you learn that those rocks tested positive for organic molecules, long-chain carbon-based compounds. That's not the same as life, but it's part of the recipe. And these molecules weren't floating on the surface. They were buried in rock, protected, stable. Now think about what that means. You're looking at a photo of dust, and that dust might be holding the key to whether life ever started on another planet. That's not speculation. That's what the instruments are designed to look for. And that's what the images are silently capturing, over and over again. Even the colors in these photos matter. A rusty patch might mean iron oxidation. A pale one could mean sulfate. In some close-ups, you'll see greenish tints. That's olivine, a mineral that can survive in volcanic environments, but also reacts with water. It tells you both how hot the rock was and how wet it got afterward. So, just by looking at a picture, scientists can start to reconstruct entire timelines of heat, erosion, and chemistry. These aren't just pretty images, they're evidence. And the fact that they're publicly available means anyone with the time and the curiosity can sift through them and discover something new. We're not just watching Mars, we're slowly decoding it. And with every photo, no matter how quiet, no matter how small, we're learning how to read a dead planet's history from the patterns left in its dust. The images we're seeing from Mars today are all taken by machines, automated, engineered, and pre-programmed. But one day, those photos might come from someone's gloved hand. A human being standing on Martian soil, pointing a camera at the horizon, not because it's part of a mission plan, but just because they felt like it. That moment hasn't happened yet, but we're getting closer. And when it does, the way we look at Mars will change forever. Right now, every image goes through a process. It's captured, compressed, beamed across space, cleaned up, sometimes color-corrected, and then published. But human eyes don't need a data pipeline. They need a visor. They'll see Mars in real time, with depth, with motion, with atmosphere. And that difference matters. For decades, scientists have used real images to reconstruct what it would feel like to stand on the surface. They stitch together panoramas from the Mars cam. They simulate Martian sunrises using light data, but all of that is still filtered, still secondhand. No one has stood in a Martian dust storm, watched the sunlight fade to blue, or turned their head to see Olympus Mons rising on the edge of the sky. No one has walked into a crater and looked up at the rim, surrounded by silence in every direction. Those are the images we don't have yet. But they're coming. And here's the thing. Humans won't just take better photos, they'll take different photos. Candid ones, casual ones. A selfie in front of a rover. A crew member holding up a rock sample with a thumbs up. A shot of a boot print next to the American flag. Or next to nothing at all. These images won't be scientific. They'll be personal. And they'll change how people back on Earth see Mars because they'll see someone like themselves standing there. That's already part of NASA's plan. The Artemis missions are getting ready to test technology that'll eventually be used on Mars. Advanced spacesuits, designed to withstand abrasive Martian dust and extreme cold, are being refined on lunar soil. Modular habitats, capable of shielding against radiation and sustaining life in alien environments, are taking shape. Next-generation transport systems, from rovers to reusable landers, are being stress-tested to ensure they can navigate Mars's rugged landscapes. Meanwhile, private companies like SpaceX are building toward crewed missions. We're still years away, but the goal is real. And when that first astronaut steps out and points a camera at the Martian surface, the photo they take will be the most important one in the history of space exploration. Not because of what it shows, but because of who took it. But even before that moment, images are changing. We're already testing color-calibrated lenses that simulate what Mars would really look like to the naked eye. Most of the red we see in photos is exaggerated by filters. In reality, it's more muted, brownish red, sometimes gray. The sky isn't always red either. At sunset, it turns blue around the sun. These details will be captured differently by human photographers. They won't just be taking pictures for science, They'll be taking pictures for history. And beyond the photos themselves, there's the question of presence. When a person is behind the lens, they decide what matters, what to capture, what to ignore. A robot will take a picture of a rock because it was programmed to. A person might take a picture of that same rock because it looked like something they saw as a kid. That difference, tiny, emotional, human, is what will make those future images powerful. Right now, we're still relying on machines to send back photos one batch at a time. But soon, someone might be live streaming from Mars, showing us what it's like to look up at a pale Earth in the sky, to climb a slope and rest at the top, to take a photo not because it's required, but because it's beautiful. And when that happens, we'll finally stop seeing Mars as a destination and start seeing it as a place people can call home, even if only for a while. The thousands of real images we've collected from Mars tell us a lot about the planet. But maybe they tell us even more about ourselves. Because think about it. We've spent decades building machines to take photos of a place no one's ever been, just to answer questions we're still not even sure how to ask. That says something about human curiosity, about how far we're willing to go to understand a world that doesn't care if we're watching. We didn't send cameras to Mars because we expected something dramatic. There are no cities, no creatures, no monuments waiting for a photo op. We sent them because we couldn't stand not knowing. We looked at that red dot in the sky for thousands of years, and when we finally had the technology to reach it, the very first thing we wanted was to see it. Not through guesses or drawings, but directly. With our own eyes, even if those eyes were made of glass and wire. And what did we see? We saw a planet that looks like it was halfway through becoming something before it stopped. A place shaped by water, scarred by impact, layered by time, and then left to freeze and dry out. It's easy to forget that Earth and Mars formed at the same time, from the same material, in the same solar system. Mars didn't fail. It just didn't last. And these images quietly remind us of that. They show us a version of what Earth could have been, or what it might still become. But they also show something else: determination, creativity. The fact that humans can build something as complicated as a rover, land it on a moving planet millions of kilometers away, and have it take high-definition images of a rock from billions of years ago, without anyone ever physically being there. That's not just impressive, it's ridiculous. And yet, we've done it. Multiple times. Every image from Mars is proof of that effort. A reminder that science isn't just about equations and theories. It's about building things that let us ask better questions. It's about looking closely at something that seems empty and realizing it's full of meaning. A rock on Mars isn't just a rock, it's a timestamp, a clue. A piece of a puzzle that might never be fully solved, but is still worth trying to understand. We stare at these images and ask, did life ever exist here? Could it still exist under the surface? What went wrong? And beneath those questions, there's always the unspoken one. Are we alone? That's what these pictures are really about. Not the dust or the cliffs or the craters, but the fact that we're still searching. Still asking, still sending cameras across space, hoping to see something that helps us make sense of ourselves.